This time we're supposed to find the instantaneous voltage for each of the following examples. Remember, we are going to use the calculator and make sure that anytime you are going to see the angle expressed in degrees, your calculator has to be switched to degrees. Anytime the angle is expressed in radians, you have to make sure that the calculator is going to be switched to radians. Now, what we're supposed to do, if you want to find the instantaneous voltage for this formula, simply write V is equal 45 sine 34 degrees. Use the calculator and type 45 sine 34 is equal 25.16 volts. This is the instantaneous voltage at angle of 34 degrees. What I mean by that, if you have sine wave and this is your 90 degrees and your peak voltage is 45 volts, the voltage at 34 degrees, somewhere over here, is going to be equal 25.16 volts. This is basically what it means. This formula, this is the formula for the sine wave, allows you to calculate the voltage at any point of the sine wave. Let's take a look at the second example. Again, we are going to use the calculator. Simply type into the calculator 2 Torre sine an angle of 220 degrees. This is equal minus 147.84 volts. So how it look like? You have the sine wave, and in the middle you have 180 degrees. Over here there is 270 degrees, and your angle is 220. Let's say somewhere over here. And the voltage at this point has to be negative and is negative 147.84 volts. This is basically how it looks like on the graph. Now, let's take a look at this example. We're supposed to find instantaneous voltage at angle which is expressed in radians. Please make sure that this time you are going to switch your calculators to radians. And simply type 85 sine 3.6. And the answer is minus 37.61 volts. How it look like on the graph? I have sine wave. My 180 degrees, which is half, in radians is simply pi, and pi is 3.14. We got 3.6. This is a little bit more than 3.14. So if this is my 3 pi over 2 over here, which is 1.5 pi, this angle is going to be somewhere over here. And the value is supposed to be minus 37.61 volts. This is the solution to my problem.